So, how does this work? Well, let's see. Where did my pen go? Where did my pen go? Well, all right, let's just do it. All right, so factoring by grouping. So by grouping, you're going to factor twice. And I want you to write this down. A times B plus C plus 5 times B plus C. I want you to write that down. A and B and C are just numbers. That's the thing with variables. They're just numbers. They're just numbers we don't know. They're numbers, but we just don't have a clue what they are, okay? So, when I look at this, do we have that written down? Okay, put your phones away. Phones away. When I look at this, they have these, I see 2 parts. You guys see 2 parts? I see 2 parts. I see, because the plus sign in between, they really both have a B plus C in common, don't they? So if they have a B plus C in common, I'm going to write down what they have in common. Okay, so what do they have in common? In common is my B plus C. So if they have in common a B plus C, and I factor out a B plus C, what's left over is the A plus 5. Now that seems weird because I see two B plus C terms, right? Don't you? Now we're at 1 down, correct? But if I multiply the B plus C to the A, well, I get an A times a B plus C. And if I multiply B plus C times the 5, I get a 5 times a B plus C. So this is kind of factoring we want to do today. So by grouping, when we do by grouping, we're going to find 2 parts first. We're going to pair them up. 2 parts first, we're going to pair them up. Pair them up. Okay? So when I look at example 1, Gretchen, have you seen this before? Okay, you might have. So when I see 4 terms, write that down. When I see 4 terms, we're going to go grouping. 4 terms. You see 4 terms? 1, 2, 3, 4. We're going to pair them up, okay? See 4 terms, going to pair them up. So when I take a look at the first pair, let me just ignore it. I'm just going to cover it up. Look at the first 2. We're pairing them up. What do they have in common? The first 2, what do they have in common?
3 and an x.
Good. So let's do it. Let's take out a 3 and an x. And what's left over if we take out a 3 and an x would be a x squared. Actually, let's take out a 3x squared. Let's take out even more, Scott. How's that? You okay taking out a 3x squared? So if I take out a 3x squared, so what's left is just an x minus 4. All right? So 4 terms. 1, 2, 3, 4. 4 terms. Pair them up. We did. Take a look at the first pair and common factor. We did that. Take a look at the second pair. I'm going to put a plus sign here. And what do these 2 have in common? They have a 2. And if I take out a 2, what's left over? Minus 4. Okay, now, what do the 2 pairs have in common? So I'm going to take out the x minus 4. Now, I like to cross it out so I don't get confused. That's just my method. And what's left over? That's our answer. Okay, it's different. You haven't seen this type before. Okay? Let's take a look at the next example, right? Example 2. 4 terms. 1, 2, 3, 4 terms. You guys agree? So if you have 4 terms, we're going to do by grouping, so pair them up. These 2 with these 2, okay? 4 terms, pair them up. Always. All right? So let's cover up this. Just ignore this for just right now. What do the first 2 have in common? A 2a, good. Totally right. So we take out a 2a. Good job, Calvin. So if I take out a 2a, I'd have a plus a 4b. You okay with that? All right, and you can go backwards to get it. If I take out a 2a, I'd have a 2a plus a 4b. Now, let's look at the second terms. They have a negative in common, don't they? They have a negative 3 in common. Okay, you guys see that? They have a negative in common, and they have a multiple of 3 in common. So if I take that out, I'd have an a plus 4. Now, where'd that plus come from?
4B.
And thank you. Yeah, the negative. Yeah, the negative. Totally.
Negative and negative.
Right. Good answer. Okay. Now, what do the two pairs have in common? Yes, we just write that down. A plus 4b. What's left over? What do you think? Oh, I keep 2a plus 3. Slide up. Okay, you guys try this one. Try it on your own without me, okay? Well, I don't see a whole lot in common. Could we rewrite it? Sure, what do you think you want to rewrite and put together? Okay, I don't really like the pairing up.
You could do the 2x.
That's probably great. Let's do the 2x cubed with positive 3x squared together, right? And then we'd have a negative 18x minus 27 together. I like that idea. So I didn't see anything in common between the first two pairs, right? So then let's just rewrite it and put things together that go together, right? These two go together. These two go together, right? All right. Now, what do you see in common? X squared. I heard somebody quietly say x squared. I agree with that. X squared in common, right? And if I take out an x squared, what's left inside? 2x plus 3. Good. And what about this pair? Okay, what about this pair? What do these two have in common? Yeah, how about I like that. How about a negative 9? You okay with a negative 9, Scott? And then, what would be left inside? 2x plus 3. You okay with 2x plus 3? You okay with the plus 3? I think Grace said the negative, right, Grace? You said that earlier up here, right? Didn't you say that? I don't know. Okay, what are the two? Now, what do the two pairs have in common? Sure. What's left over? Now, this is a weird one because this one can be factored a third time. We can do more. Anybody see? I can do more. What do you see? I agree. So this one we're going to take even further. We've got our 2x plus 3, and then we're going to have a x plus 3, x minus 3. Wow, it's getting hard. How come it got so hard all of a sudden? Why not? You guys are smart. You can do it. All right, example 4. We're getting there. Now I got to solve. So to solve, I'm going to have to factor, get many equations. Before I do anything, it has to equal 0, right? It has to equal 0. If we're going to solve, it's got to equal 0 first, okay? All right, I'm going to bring over the 7x squared. So I'm going to subtract it. I don't want to show that step. We're in geometry. We're not in algebra, so I'm going to go minus 7x squared. So I'll have a 4x squared. I'll go minus 7x squared. I'm going to bring over the 16x by doing what? How am I going to bring over the 16x squared?
4x is cubed.
Oh, thank you, Scott. It's early for me too, isn't it? Thank you, Scott. And then how am I going to bring over the 16x squared? Subtract it, right? Minus it, right? And then plus my 28 equals 0. Okay? So 4 terms, right? 4 terms. What did I say? 4 terms. We pair them up always, right? So we got 4 terms. Let's pair them up. I want to put these two together and these two together, okay? So what do you see? The first two, what do they have in common? X squared. And what would come out is an x squared. What's left inside?
4x minus 7.
Good. Oh boy, what do you think they have in common? Yeah, how about a negative 4? How about a negative 4? Because that way I get that to be a 4x minus 7. Okay, take a look at what I did. See if that makes sense. Because the idea is to try and get something the same, right? That's what we want to do, is get the same. You okay with the negative 7? Because negative times a negative is a positive. Okay, now what's my next step? What's my next step? What are these? Oh, you're way ahead of me. Tava, yes, but you're ahead of me. Okay, thank you. You're way ahead of me. So these two have a 4x minus 7 in common, right? And what's left over is x squared minus 4. Hold that thought, Tava, for just a second. You're way ahead of me. I like that. It's awesome. So 4x minus 7 is what they have in common, correct? I take that out. What's left over? X squared minus 4. Now, Tava said, Tava, what did you say?
X plus 2x minus.
So she saw the next step. So we're going to factor this one again. 4x minus 7, and then I have an x plus 2x minus 2, right? Now, I need to solve. It says solve, right? Doesn't it say solve? I have many equations, right? I should get 3 answers. I should get 3 answers. Got to get 3 answers because there's an x cubed. Thanks, Scott. I almost lost my x cubed. So, one mini equation is 4x minus 7 equals 0, okay? Another mini equation is x plus 2 equals 0. And another mini equation is x minus 2 equals 0, okay? So we'll solve. Plus 7 plus 7. I get a 4x equals 7. Divide by 4, divide by 4. And 7 forces one answer. All right? Minus 2, x equals negative 2. Plus 2, x equals 2. So we've got 1, 2, 3 answers, okay? How am I doing? Am I going too fast? Okay, you ready to turn the page? We're almost there. Okay. Okay, so example 5. This is kind of a little bit of what we did earlier. What do you see? What do you see? A 2x in common, right? So if I take out a 2x, what's left over? Minus 1, right? Can that be done again? Again? Can something be done again? Can something be done again? Can I factor something again? Maybe. What times what makes 1?
1.
What times what makes negative 1?
1 and negative.
There you go. How about if we go 2x and do an x plus 1, x minus 1? Would that work for you? We factored it twice, right? How about example 6? What do you see? 6x, right? You guys agree with that? What's left inside?
Wait, so for example 5, is that the answer?
That's it. We can't go any
You
further.
don't have to solve.
Great question, Scott. Really good question. So what we're looking for is an equal 0.
Oh.
If we have an if we have an equal sign in the word solve, we got to do many equations. Okay, really good question. So we're done, right? How about example 6? I agree. Take out a 6x. What's left inside? What's left inside? Okay, good. Now that won't. We can't do anything with that. Oh no, we can. Oh, we can do it again. We can do it again. Boy, it's early for me too. Can't believe I missed that. We can do it again. Can't believe I almost missed that. Minus 2, x minus 2, x minus 2. Awesome. And again, Scott, there's no equal sign, right? No equal sign, no solve. Done. But number 7, what do you see about number 7?
Wait, so because did you divide by 2 for that last one?
No, I went what times what makes 4 that adds up to negative 4.
Oh,
Right? You asked good questions, Scott. Thank you. Okay, example 5. Or 7, sorry, example 7. What do you see? What do you see? 2x cubed, yeah. They have a common 2x cubed, okay? So then what's left inside? X squared plus a 1x minus 72, I think. Can we do that again?
Next, 70.
That's a 72. How about 8 and 9? I like 8 and 9. Do you guys like 8 and 9? So I probably a positive 9, negative 8, right? Probably because, oops, I forgot my x. Because that would make a positive 1 when I add them and a negative 72. Now, Scott, you asked great questions. Now we need many equations because the equals 0, right? So now I need many equations because I need to solve it. It says solve. So I'm going to say, okay, 2x squared equals 0.
Wait, is it still squared or is it cubed?
Ah, yeah. It's like, thank you. Yeah. Thanks, Scott. Thanks for catching my mistakes. Boy, this daylight savings times. Yeah, Tava?
I thought the highest exponent was how many answers you got.
Right, so we need 5 answers.
Right.
I was hoping somebody would ask that. I'm going to answer that second in just a minute, okay? So divide by 2, x cubed equals 0, right? Which is, Tava, x equals 0, x equals 0, and x equals 0. So 0 happens 3 different times at the same time, but that's just 0, isn't it? Isn't that just 0? And I'm going to show you how that works graphically. Minus 9, x equals negative 9, plus 8, x equals 8. Okay, Tava, the graph looks something like this. Okay, I want you to watch what I'm going to do, okay?
Or does it go up and down?
It's going to go like something like this, okay? It's going to go like this. It goes through 9, negative 9, because that's one answer. Scott, what you said is completely right. It's going to go, watch this, it's going to go through 0, back through 0, and back through 0 again, and then through 8. It gets this really weird little bumpy thing, but we're getting into like stuff I want to talk about next week. That's called a triple root. It's a triple answer. And again, you asked a great question, but we're not going to worry about that yet. But the 0 happens 3 times. Isn't that weird? Okay, we're going to take a mass break real